using graphs and tables to solve systems. Intersection point of the graphs of two models. If the independent variable of two models represents time, then an intersection point of the graphs of the two models indicates a time when the quantities represented by the dependent variables were or will be equal. Three types of linear systems. The first type that we're going to talk about is when the solution set of a system of two linear equations can be found by locating an intersection point of the graph of the two equations. A linear system that has one solution is called a one-solution system, which is our first type of linear system. In this example, find the solution set of the following system by graphing the equations y equals 1/3 x plus 8 and y equals -1/2 x plus 3. Since both equations are in slope-intercept form, I'm going to graph them by finding the slope and the y-intercept. For my top equation, y equals 1/3 x plus 8, the slope is 1/3, and my y-intercept is 8. So I plot my 8 on the y-axis, then I go up 1 over 3 to make my second point. This is all I really need to graph my equation. If you need more points, you're welcome to graph them, and then you want to draw your line. Now I have the line for y equals 1/3 x plus 8. So I'm ready to graph my other line. For y equals -1/2 x plus 3, my slope is a -1/2, and my y-intercept is 3. So starting with my y-intercept, I then go down 1 over 2, and I can do that as many times as I need to, making as many points as I need. Then draw your line. Now that we have both of our lines on our graph, we're ready to figure out if they cross. So my answer is -6, 6. We want to make sure our point -6, 6 works in both of our equations. To check this, we're going to substitute our answer -6, 6 into each equation. So 6 will equal 1/3 times -6 plus 8. 6 equals -2 plus 8. 6 equals 6. So it works for our first equation. For our second equation, 6 equals -1/2 times -6 plus 3. That means 6 equals 3. Bring down your plus 3, and 6 equals 6. So we know our answer is correct. A linear system whose solution set is the empty set is called an inconsistent system. In this example, find the solution set of the following system by graphing the equations. 3x minus 5y equals 30. 6x minus 10y equals 30. Since they are in standard form, the easiest way for me to graph the two equations will be to use the x and the y intercepts. When you find your x-intercept, you let y equal 0. So I have 3x minus 5 times 0 equals 30. Or I can just start with 3x equals 30. Dividing both sides by 3, x is 10. So my x-intercept is 10, 0. For my y-intercept, x is 0. So 3 times 0 minus 5y equals 30. Or I can start with -5y equals 30. Divide both sides by -5, and y equals -6. The y-intercept is 0, -6. So to graph this line, I want to plot the points 10, 0, and 0, -6. So now we have our first line graphed. So now we're ready to graph our second line, 6x minus 10y equals 30. Let's start by finding my x-intercept, which means y is 0. 6x minus 10 times 0 equals 30, which means 6x equals 30, x equals 5. So I have the ordered pair 5, 0. For my y-intercept, my x has to be 0. 6 times 0 minus 10y equals 30. Negative 10y equals 30. Divide both sides by negative 10, and y is negative 3. So our y-intercept is 0, negative 3. Now we're ready to plot our two intercepts and graph our line. The two lines are parallel. The system is inconsistent and the solution set is the empty set. You can draw the symbol for the empty set by drawing a circle and drawing a line through it. A linear system that has an infinite number of solutions is called a dependent system. In this example, we want to find the solution set of the following system by graphing the equations y equals negative 3x plus 3, 6x plus 2y equals 6. Since y equals negative 3x plus 3 is in slope-intercept form, I'm going to use my slope, which is negative 3 over 1, and my y-intercept, which is 3, to graph the line. Plot 3 on my y-axis, then I go down 3 and over 1, and I do this as many times as I need to graph my equation. Now that I have my first equation graphed, I'm ready to graph my second equation. Finding my x-intercept, that means my y is 0, 6x equals 6, x equals 1, so I have the point 1, 0. For the y-intercept, my x is 0, so I have 2y equals 6, y equals 3, so I have the point 0, 3. When I draw my line, I have the same line I did when I graphed y equals negative 3x plus 3. So that means the system is dependent and the solution is all the points on the line. I can write my solution as all points on the line or just write same line. In this example, I want to use intersect on a graphing calculator to solve the system. Round the coordinates of the solution to the second decimal place. I have y equals negative 2.58x minus 6.47 and y equals 1.74x minus 1.63. Using our graphing calculator, we want to first go to y equals and then type in each line. Make sure you use the negative symbol, negative 2.58 minus 6.47. I've forgotten my x. Using my left arrow, I arrow to this position where I want the x, which is before the minus sign. Second, and the delete button allows me to insert. Now you can see that it is alternating between the minus sign and a line at the bottom. I push my button xt theta n and it types in our x. I'm going to down arrow because now I have the equation I want, negative 2.58x minus 6.47. Typing in my second equation, I have 1.74x minus 1.63. Now that I have my two equations, I'm ready to graph my line. I'm going to go to Zoom, and we're going to start with standard, which is 6. Here I have an error, invalid dimensions. So I'm going to press enter, go to stat, press enter for one edit. What this means is I don't have any data in my lists. Go to second, y equals for stat plot. One of my stat plots is on, so it's trying to graph points that don't exist. So I have two options on turning this off. I can press enter and turn it off here, arrow over to off, press enter, or press y equals. You'll notice I have plot 1, plot 2, plot 3 showing at the top. I can always arrow up and press enter here to turn it on, enter to turn it off. So let's try Zoom again. Zoom, I'm going to go with 6 standard. And I have my two lines. Now it's important that the place where they cross is visible when we use intersect on the calculator. If you cannot see the place where they cross, intersect will not work. You can always go to Window to change your X-min, X-max, Y-min, and Y-max so that you can see where they cross. So now let's do second and trace, which will give us calc. We want intersect, which is 5. And it will ask you if this is where you think the first curve crosses with the second curve. I get where I think they cross, press enter, second curve enter, guess, enter, and then it gives me the intersection. With the TI-83 and the TI-84, I don't actually have to move the dot to where they intersect. If I just press enter 3 times, it will give me the intersection. So my intersection, x is negative 1.12037, y is negative 3.579444. So my answer is negative 1.12, negative 3.58. Using graphs and tables to solve systems. We have 3 types of linear systems. Our first type of linear system has one solution. That's where the two lines cross in one spot. Our second type of system is an inconsistent system. It's where we have parallel lines and our solution is the empty set. Our third type of graph is the dependent system. This is where they are the same line and the solution is all numbers on the line, or you can just write same line.